Okay, guys, so I'm going to take a minute and talk about determining rational roots. So we're going to talk about rational roots. So we work with small perfect squares and small perfect cubes. So I'm going to write a couple examples here. Let's see. Sorry about that. X squared equals 25. Maybe x cubed equals negative 8. X squared equals 0. X cubed equals 1. Let's say x squared equals negative 64. X cubed equals 27. Let's do one more. X cubed equals negative 1. Okay, so there's a couple ways to think about these. One is that you could ask yourself, what number squared would get me 25? So really we want to think about that backwards, or taking the square root of x squared. And so that would leave me x equals, and then the square root of 25 is 5. However, 5 is not the only thing that I can square to get 25. I can also square negative 5. So I can do the positive or the negative, because we know that 5 times 5 equals 25. And negative 5 times negative 5 also equals 25. So I have two solutions, two rational solutions. Okay? So here I'm going to do the same thing with negative 8. So I'm going to ask myself, what is the cube root of 8? Okay? And so then I know that that 2 times 2 times 2 is 8. Well, that's positive 8. So then that won't work. So what about negative 2 times negative 2 times negative 2? Okay, so does that get me negative 8? Yes, it does. So that one would work. So in this case, I only have one rational root that would work. I'm going to do the same thing for the rest of these. This is square root. So then x is 0. But what about negative 0? Well, we know that it's just 0, right? So this one would only have 1. Same thing here. What is the cube root of 1? Well, 1 times 1 times 1 is 1. Well, can negative 1 times negative 1 times negative 1 be 1? No, that would be negative 1. So this one doesn't work. So this one only has one rational root. Okay, so we're going to continue doing this for the rest of these. I'm giving myself a little room here to work. So take a minute and think about, what do you think? How many rational roots does this have? Okay, so I'm going to take the square root of this. So I got a little too carried away there. So square root, oh, wait a minute. Is there any way to square 8 and get a negative 64? Well, 8 times 8 is positive 64. Negative 8 times negative 8 is 64. So this one has no rational roots. Here, again, I'm going to take the cube root. Well, that would mean that x is 3, because 3 times 3 times 3 is 27. So I'm going to ask myself, does negative 3 work for that? Well, that would be negative 3 times negative 3 times negative 3. And we know that that would be negative 27. Nope. So this one only has one option. Same thing here. I'm going to say the cube root of negative 1. Alright, so I'm going to question, well, if I say 1 times 1 times 1, that gets me positive 1. So nope, that doesn't work. negative 1 times negative 1 times negative 1. Yep, that gets me negative 1. So this one only has one rational solution. All right, so I hope this helps clear some things up. I do want to talk about one more thing, and that was what happens when you have this. Well, I'm going to try to do the same thing. I'm going to take the square root and the square root of both of those. So this is still going to be x, but one thing that you may not know is that another way to write this is the square root of 1 over the square root of 16. So you're basically thinking about the same thing. The square root of 1 is 1, and the square root of 16 is 4. So I'm going to say 1/4 times 1/4. All right, that would get me 1/16. So, yep, that works. Negative 1/4 times negative 1/4. Well, that would also get me 1/16. So this one still has two rational roots. The only difference is that this one was a fraction, and so that tends to throw people sometimes. Let's try one more. Let's try a cube root. Let's say you have the cube root of negative 1 over 27. Well, just like on the first page, I'm going to take the cube root. So that's going to be x. And so we know that the cube root of 1 is 1, and the cube root of 27 is 3. So we're going to try this with 1/3. And see if that gets me negative 1/27. This one gets me a positive 1/27. So then I would try it with negative 1/3. And so that one would be negative 1/27. So this one works. So think about this and write out some general rules that you could think about if you look back and forth at these with squaring and cubing, and see if you can come up with some generalizations. All right. Good night, guys. Thanks.